the chemical properties of base, which will be handled by Triumph Emmanuel.
Hello viewers, once again I'm by name Emmanuel Triumph as the host mentioned. But now I'm going to be presenting to you another experiment called the chemical properties of base, precisely neutralization reaction. Now neutralization reaction can be done in two ways. First, the apparatus needed for the first way are as follows. One, my indicator, whose name is going to be discussed about by other presenters, dropper, then my diluted sodium hydroxide, this serves as the base, diluted hydrochloric acid, this serves as the acid, as the name implies, and the beaker where the base and the acid are going to be mixed together. First things first, let's get to work. I'm going to pour a little amount of diluted hydrochloric acid in the beaker. That's it. Cover it. And then to test whether this substance is acidic, my indicators comes to work. Just drop a little amount. Wow, it turns red. This is to show that this substance is really acidic. Then I'll get the base and pour it into the substance until it changes color from red to yellow, and this is also my salt solution. The balanced chemical equation for this reaction is sodium hydroxide in aqueous form, which chemically combines with hydrochloric acid also in aqueous form. This will yield salt and water, that is sodium chloride and H2O. See, this reaction is similar to that of Mr. Munibu's, but that the only differences there are the color of the results and the indicators used. Now furthermore, I told you earlier that there are two ways of this neutralization reaction as chemical property of base. I've done the first one, let's move on to the second one. Now this is the second way of the neutralization reaction. The apparatus needed for this are as follows. 1. A petri dish containing copper oxide. This is a metallic oxide, as you can see. Diluted sulfuric acid and conical flask. This is where the copper oxide and the sulfuric acid are going to be mixed in. And let's get to work. I'll first of all pour carefully the copper oxide, the metallic oxide, in the conical flask. Pouring it carefully to avoid much loss. That's it. And then pour it in the conical flask containing the copper oxide. I'm stirring it carefully to avoid spillage. Keep on stirring it. We got a black colored solution after adding sulfuric acid to it. I keep on stirring it carefully and then allow it to rest. That will be the second stage. Actually, we're working towards getting a color, and we'll see if I get that color. So and then I'll allow it to settle now. Settle down. It's settling. Viewers, as you can see, there's a color change. There's a change in color. The black, it has almost turned to blue completely. Still pick it up. Getting the blue color already. This is my salt solution. going to keep on swirling it. I said earlier, I was working towards a color and I'm almost achieving that. As you can see, it's blue, but it's still not blue enough. Viewers, this reaction takes a lot of time, but nevertheless, sit tight. Still going to keep on swirling it carefully to avoid spillage, and then I'll allow it to rest again, to settle, to get the blue color. Like I said earlier, I allowed it to settle, and then I got the color I told you I was working to. That is cyanide blue. This is it. And if you look closely, you see a black tint here. That is a metallic oxide. This is to show you that it actually takes time to settle. It actually takes time to react. I meant. And this is it. I've gotten it. The balanced chemical equation for this reaction is copper oxide in solid form, which chemically combines with sulfuric acid in aqueous form, yields copper 2 sulfate in aqueous form, and water H2O. This is our copper 2 sulfate. We've successfully done the two methods of neutralization reaction under the chemical property of base. Thanks for watching.